My name is Shirley Dyke. I'm a professor of mechanical and civil engineering. And I look forward to a set of very inspiring talks and a lot of ideas that spark discussion about this topic. We started this project with the idea that we've been building habitats here on Earth for thousands and thousands of years. And yet, we know nothing about the environments, or very little about the environments that we're going to in this new phase of human exploration. And we need to figure out how to apply all of these techniques, all of the knowledge about the hazards, how to deal with them, about how to just build in these environments to this new phase. We have to figure out how can we do that. So we decided to bypass the step of getting there because there's a lot of people, including some in this room, working on that. But what we wanted to do was to jump straight to the questions that we're going to have to address when we get there. So this is the lineup for today. I'm going to introduce the agenda and the objectives before we go ahead and get started with the plenary session. First of all, we're going to have a plenary session where we have 3 excellent invited speakers. The idea behind these presentations and the panel discussion is to spark the discussions, to figure out what we're going to talk about during the discussions, maybe target some things that would be particularly important. The focus, or the title, the subtitle of this workshop is Challenges and Solutions. And I think we're going to mostly talk about challenges, but maybe we can point in the direction of some of those solutions. So after the plenary session and a Q&A session on that, we'll have a brief break, and then we'll have the panel session, which Professor Bobette is going to moderate. We're going to have a brief group picture. Where's the group picture going to be held? PMU stairs. So the stairs where we go up the main staircase? Okay. So it's right in the next building. So at lunchtime, we'll go over there, we'll take a group picture, and then we have a lunch, and then we have 3 breakout sessions, which I'll talk about in a second. A brief break today, and then we're going to go into a reporting session on the breakout. So there will be a note taker in each of the group breakout sessions, at least 1, maybe 2, taking notes on that discussion so that we can write a report at the end of this event. Tonight we're going to have a poster session and a reception. So there'll be some hors d'oeuvres, some drinks, and a poster session where many of the students and the student teams have put together posters on a variety of different topics. I think we have almost 20 posters, so that should be quite nice. And then we'll wrap up the evening. We'll start up tomorrow again at 7:30. So what is the purpose of the workshop? We've said it a couple times, but the idea is to discuss the challenges associated with establishing and operating permanent habitats on other planets. To identify the research questions that we have, the key questions that we have to answer to get started on this. There's so many, but what are the key questions? What are the first things that we have to address? Maybe what data needs to be collected in order to get there? And to discuss the types of research needed in order to address these questions. So these are the 3 breakout sessions. Obviously, this does not cover the extent of all the questions that you could ask about extraterrestrial habitats. But we wanted to focus on a few key areas. What are the hazards is one of the first questions. What do we know and what do we not know about these really harsh environments? Secondly, the resources. What new technologies are needed in order to harvest these resources and then use them for the purpose intended? And thirdly, the habitats themselves, we need to explore. We've done this on Earth for thousands of years, again. But where and how do we build something that's safe and resilient on another planet? All of these questions really have to incorporate all sorts of science and technology. We have to be able to bring these things together. So with that in mind, these are the 3 speakers that we have for this particular session. First speaker is Dan Dumbacher, and Dan is currently the Executive Director for the American Institute of Aeronautics and Astronautics, which is the first professional organization I ever joined. He had a brief stop at Purdue, which we enjoyed having him here for a couple of years. Before that, he was at NASA for many years. He was a recipient of the Silver Snoopy Award and the Distinguished Service Medal at NASA. And he was involved in many different projects, including the Space Launch Systems and the Orion, in charge of a budget of about $3 billion. Dan? And I'll introduce the other two speakers as we get to them. You can either...
Oh, probably. I prefer to walk around. Good morning, everyone. How is everybody doing? Okay, so how many of you are Purdue grads? You want to flip it on? How many of you are Purdue grads? I cannot resist the happiness from Saturday night. Come on. As my son would sit there, and he knows that Dad watches Purdue football, and Dad is always convinced Purdue will eventually lose it. I was not convinced we were going to win until, about 3 minutes left, when that interception got ran in for a touchdown. I'm like, okay, this is done. We're good. But I want to welcome everybody. And first of all, Shirley, don't let me go too long. You make sure you keep the hook on me. For those of you who don't know my background a little bit, Shirley kind of touched on it, but I'm going to go back and emphasize a couple of things. Number one, after 33 years at NASA, and my last job as the Deputy Associate Administrator for Exploration, if any of you know Bill Gerstenmaier, I used to have to put up with him as a boss, and he had to put up with me. For the record, this is another little sidebar, I can't resist this one either. We talk about all the great Purdue astronauts, and I love my Purdue astronauts. But for the record, when I was back at NASA, your Associate Administrator for Exploration, your Deputy Associate Administrator for Exploration, your Orion Program Manager, your Orion Chief Engineer, your Orion Chief Safety Mission Assurance Officer, your Orion Lead for Software, and a bunch of the propulsion people at the Marshall Space Flight Center all came from what university? The one that beat Ohio State on Saturday night. So my point is this, there's a lot of expertise here, but there is also a lot of expertise around the world and around the United States. And the value of what's going on here with RETH is absolutely essential. Back when I was working at NASA and we were focused on getting the Space Launch System and Orion up and running and getting those programs started, we also started to think about the future and where is it going. Now, at the time, because of political purposes, we were talking about near-Earth asteroids and Mars. And some of us were looking around going, did we forget something here? And as I like to explain to people, and I would say this back in the agency, and I will say it now publicly, by the way, the beauty of being a Purdue faculty member, which for some reason they still kept me on the list, and being at AIAA is the fact that I can now say what I think, and I don't have to clear it through OMB or the administration. Some of you will understand how important that is. The message is this. When you first take your kids camping, do you take the first camping trip to the Grand Canyon? No. I train them a little bit in the backyard. We go to the local county park. We go to the local state park. We do a couple things overnight. And we gradually build our capability and our training, and we move out. Does that analogy apply to exploration at all? I would submit yes. Now, some of you know, particularly my Huntsville friends who are here, they might remember, that Dan drives around with a car with his license plate tag that says, "On to Mars." And I still firmly believe that. I still want to go to Mars. My dream in life is to be sitting in my backyard looking up at Mars with a gin and tonic in my hand, knowing that the younger generation has finally accomplished what I wanted to do. That said, we need to go to the moon first. And the switch that has occurred over the last year or so is the right switch, and this is the right research project to help us figure out what we need to be doing. Now, I would like to make a point here. When you look at habitats for the moon or even habitats for Mars, what do you always see? This is audience participation, by the way. What do you always see? Huh? Domes. Jay, you're cheating. You're not supposed to. Everybody else is supposed to be answering. What do you always see? You always see domes on top of a surface. Why do we assume that? Why do we assume that? Pardon me? Similar to Earth. I would submit that the importance of this project, for no other reason, is at least to test that assumption and to put another bit of information and research onto the table for us, and this is a royal us, this is a global us, to determine how we want to move forward on space exploration. For a couple of reasons. Not just from the safety of habitats and dealing with radiation environments and dealing with everything else we have to deal with, but also from the fact of, can we utilize the resources better? And what can we learn from this that we can take to Mars? And oh, by the way, some of us want to go to a few other places along the way. This does not stop at the moon. It does not stop at Mars. These are steps to learn along the way. And we need to think of it that way. We need to think of it in those terms. Now, we have some really hard questions to answer. But the research has shown us, and yes, I am a little bit biased because I was working with the team before I left Purdue to go to AIAA. But this is important research in the sense that it starts to put another option on the table, and it actively starts to put real engineering to these pictorial concepts that everybody points to and says this is the way it's going to look. Even those domes that you see in the pictures don't have a whole lot of engineering behind them. They've got artist concepts. I've got what people think it might be, but nobody's put some research down to it. Nobody's put numbers down to it. And if you're asking the NASA team to try to figure out what the next steps are, do you really want the NASA team making decisions without engineering data? I would submit no. The NASA team knows and has to put forward realistic plans that can be accomplished. That's where this research project comes in, is it provides the technical backbone and the technical information of what needs to be done, how it needs to be done, so that we can determine what the best way is to move forward on exploration. So really what you guys are starting to do is city planning. Now this is interdisciplinary, and this is a technical community for the most part. But also realize that it's also interdisciplinary in terms of, if I'm going to have a group of people living on the moon, what are the laws? What are the governance structures? What are those activities? Now there's a few of you going, there he goes again, off. But all of this needs to be informed by the technical. That's the backbone here. And the backbone is, as much as we're sitting on the campus in West Lafayette, Indiana, and as much as I'm a big black and gold Purdue fan, Purdue doesn't have all the capabilities to do this. No one does. Purdue has a lot, but this team needs to be interdisciplinary to bring all of the skills necessary wherever they may be to pull them together, because the exploration efforts will be an international effort. not a U.S. only. It will be an international effort. If it's not international, we might as well stop right now. Because no single country, no single company, no single economy can afford to go do all of this. It has to be an international effort. It has to take the best and brightest of academia, the best and brightest of industry, the best and brightest of government, all the governments, to go make this happen. And that's what you guys are here, hopefully, today and tomorrow to go work on. Now, I'm one of those dumb program managers out of NASA headquarters. So when I left the Marshall Space Flight Center, and some of my friends are here, they can make sure I'm right on this. They pulled my engineer card, and they wouldn't let me practice engineering anymore because you went up to the 17-mile wide logic free zone called Washington, D.C., so now you don't get to do real engineering work. I had the lobotomy as soon as I drove out of the Marshall Space Flight Center gate on my way to Washington. That said, we have some real engineering issues that we need to deal with here. How big are the lava tubes? How can we use them? What do we need to do to be able to access them? What do we need to be able to do to live in them? What do we need to be able to, how do we maintain an environment that the astronauts can survive in? By the way, as we go through this, the astronauts through our history are absolutely some of the smartest people we've ever had and some of the best physical specimens that they can be provided. They have the best of health. They can tolerate the most extremes. They are tested beyond belief. That's not going to be the case as we grow more and more into a broader community being on the moon or Mars or wherever they may be. Oh, by the way, and here's one of my big worries, we've never really been that far away from home. Right now on Space Station, I'm 220 miles up. If I have a problem, I'm an hour and a half away from getting the astronauts home. I've got a Soyuz spacecraft sitting there, and I'm an hour and a half away from home. I'm also close enough that Houston, I've got a problem, is a real thing, and I can get help from the ground immediately. When I'm living on the surface of the moon, there's a little bit of a time delay on the communications, but I'm not an hour and a half away from home anymore. I'm now 3 days minimum, and that assumes all the systems are ready to go right away. If I'm in some of the orbits that the Gateway is talking about, I can be anywhere from 5 or 6 days away from home to 9 or 10 days away from home, depending upon where I am in the orbit. Guess what? That changes the thought process, that changes the mentality of how we operate, and most importantly, it changes how we design the systems. I now have to have higher reliability. I now have to have simplicity. I have to have the ability for the astronauts to repair things on site. So now I start thinking about 3D printing, printing my parts, printing my tools. Just start to think about all of the aspects that we have to deal with. This is a start. This is a key start. And there are other people looking at similar things around the world, but this is a start. So I would like to encourage everyone to open up your thinking caps, open up the discussion, think about the new partnerships. What skills do we have that we need to work on the problem? What skills are not here that we need to go get? What research needs to be done? And how do we need to go about that so that we can inform the decision makers in terms of how we ought to go about exploration and expanding the human neighborhood further and further out, so that one day those of us over 55 can be sitting in our backyards with a gin and tonic in our hand or a beer, take your favorite, and people will be landing on Mars. We will be returning to the moon and going on to Mars. And if it's not clear, I'll try to make an even finer point on why it's important to go to the moon. We have only been to the equator on the light side of the moon. We have not been to the far side. We have not been to the poles other than robotically. And there is an awful lot to learn here. So I look forward to the discussion. I look forward to the interchange. I look forward to the debates. I look forward to the hard questions. If there's anything I can do to help from an AIAA perspective where we can go get technical committees and go get technical experts, I'll be more than happy to take those notes back and go have the AIAA help bring about the technical expertise, the policy expertise, the microgravity expertise, whatever we need, we'll be happy to go tap to go move this forward. Because this is about extending the human neighborhood and building the future for the next generations that follow. So with that, did I do okay? Okay. Right on time. Ooh, I love that. You're going to do questions later, right? Okay. So again, look forward to the discussion. Please feel free to tag me. I'm happy to talk about anything you guys want to talk about, and I'll turn it over to Shirley so that we can get on with it. Thank you.